Hello class, this is the chapter 12, summary and review. I'm going to start showing you this page if you want to take a screenshot of it or something. I have marked the things that you want to make sure that you know for this test. So that's going to include definitions of things like this. You should know what a central angle is, what a chord is, what a circle is, diameter, major arc, minor arc, radius, secant. We need to know all the terms that are listed on this page. This is page 522. Okay, then you'll notice some of these things are not marked, okay, because I don't have any problems on the test that specifically deal with these things. So I do not have arc addition postulate marked. That one's pretty easy. I do not have here 56, 57, or 58 marked, okay. Everything else is marked. You want to make sure that you know the others. But the stuff from lesson 1 about the perpendicular bisector of the chord is not going to be on this test. Okay? Okay. So let's run over the things that will be on the test. Again, making sure that you know those theorems and those definitions. Okay? So you're going to want to know about angles, okay? Okay, so we talked about an angle like this. This is a central angle, and we said that the central angle is equal to the measure of its arc, okay? So if this angle here is 30, then this arc is 30. Or if this angle is 45, this arc is 45. Okay, so that's our central angle. Okay, then we had inscribed angles. Okay, our inscribed angle written on, that means one vertex, the vertex of the angle is on the circle. Okay, and we said that the measure of the inscribed angle is half the measure of the arc. Okay, so like if this angle here was 60, this arc would be 120. Okay, the measure of the angle is half the measure of the intersected arc. Okay, then we had secant angles. Two different possibilities for secant angles, whether the vertex is inside the circle or outside the circle. Okay, so if it's inside the circle, like so, I know that these two angles are equal because those are vertical angles, okay? And then to find the measure of that angle, I'm going to take this arc and this arc, okay? So let's say this one is 70 and this one is 30. I'm going to take the sum of those, and the secant is going to be half of the sum of those intercepted arcs. Okay, so if that's 70 plus 30, that's 100, and so then my arc measure would be 50. Okay, and this one would also be 50 because those are vertical angles. Vertical angles are equal. Okay, so you take the sum of the intercepted arcs, and your secant angle will be half of that sum if it lies inside the circle. If your secant angle lies outside the circle, okay, so your vertex is outside the circle here. In that case, you're going to take the difference of these. So let's say this one is 100 and this one was 20. 100 minus 20 is 80. Half of that difference is 40. So these vertical angles here are each going to be 40. So I take the difference of the intercepted arcs and then divide by 2. And that gives me the measure of my secant angle if the vertex lies outside the circle. Okay, so I want to know my central, my inscribed, and my secant angle. angles. Okay, we also want to talk about these intercepted arcs. So an arc like this, arc like this, an arc like this, an arc like this. These are all minor arcs. Okay, your minor arcs are going to be less than 180 degrees. Okay, major arcs would be greater than 180 degrees. And then remember, if it's exactly equal to 180 degrees, that's going to be a semicircle. Okay, so we can think about that. It should have a diameter running right through it. Right, so let's find the center of my circle here, because my diameter is always going to go through the center of my circle. Okay, so if this is my diameter, then this is going to be a semicircle. Okay, now let's say that I have an inscribed angle that intercepts that semicircle. And it could be really anywhere on the circle. So there's my diameter, and here's my inscribed angle that's going to intercept this semicircle. And if this is a diameter, I know this is a semicircle, so I know that this inscribed angle is intercepting a semicircle. In that case, what do I know about this angle? Well, I know that the semicircle is 180 degrees, right? And I know that an inscribed angle, we said, is going to be half the measure of its intercepted arc. So that tells me that this inscribed angle has to be 90 degrees. Okay, this is a right angle because it's an inscribed angle that intercepts a semicircle. Okay, and that can be very, very helpful for us as we're solving problems. Okay, if it intercepts a semicircle and it's an inscribed angle, then it's going to be a right angle because it's half the measure of the intercepted arc. Okay, let's talk about another thing about inscribed angles that we know. If I have two inscribed angles that intercept the same arc, I know that those are equal. Okay, so let's say I've got an inscribed angle here. It's intercepting this arc AB here. Okay, and then let's say I have another inscribed angle over here. It's also intercepting that arc. Now I know it looks like triangles because I did end up making triangles when I did that. But remember, we're talking about angles here, so I always want to be looking for these inscribed angles. And so I have an inscribed angle here, inscribed angle here, inscribed angle here, and an inscribed angle here. And so I want to look at them and say, what arc are they intercepting? So I can see that this arc here, or sorry, this angle here, and this angle here, these angles are both intercepting arc AB. And so I know that these two angles are equal because they're intercepting the same arc. So this angle measure has to be half of AB, and this angle measure also has to be half of AB. So therefore, these two are going to be equal because they intercept the same arc. I can do the same thing over on this side. Okay, I have this angle going here. Okay, so this angle is going to intercept this arc. This angle, we can see, also intercepts this arc. So I know that those angles are also equal. Okay, then I also know that these angles are equal here because those are vertical angles. So there's a lot that I can tell about angles being equal when I have these triangles that are drawn inside circles, because really I'm making inscribed angles inside my circle. Okay? Okay, so I know that inscribed angles are going to be equal. Angles, an inscribed angle is equal in measure to half its intercepted arc, and inscribed angles that intercept the same arc are equal, and an inscribed angle inscribed in a semicircle is a right angle. Okay. Another thing I know with my arcs, let's move over to chords and arcs. Well, I can even look at that here with this one because I already have some chords drawn here. I have a chord, let's label this C and D. So I have chord BC and I have chord AD. Okay. I can look at these chords. So you have a chord, and that chord is going to intercept an arc. And I have a chord here, and it intercepts this arc. Now, these angles are intercepting these chords here. Okay? So what do we know there? Well, I'm told that equal arcs have equal chords. But are these equal? Well, this is not a central angle that I'm dealing with. So in a central angle, the measure of the angle is equal to the measure of its intercepted arc. But we can see here, this is not the center of the circle. Okay, so this is a secant angle, not a central angle. Okay, let's draw one that is with a central angle. I'll draw my center of my circle here. Okay, so I have the center of my circle. So let's start with a line there. Draw another line here. Okay, so first, what would I call these lines here? Those are radii of a circle. Remember, all radii of circles are equal. Okay, you can have pretty much infinite numbers of radii within a circle, but they will all be equal. Okay, because they're all the same distance. They're going from the center to the edge of the circle. So those are all equal. Okay, so if I have those radii that are all equal, okay, and draw some chords here. Okay, so I have these chords. So if I think of what kinds of angles these are central angles. Okay, and central angles are equal to the measure of their arc. Okay, so I have these two central angles that are equal to the measure of their intercepted arc. Okay, I also have here my chords. Okay, and I have my radii, okay, that are all equal. Okay, these are all equal. Okay, I know I have these equal angles here. I formed vertical angles here, so I know that those are equal. That actually gives me side angle side congruence. So I know that all the parts of this triangle are equal. So that means that this side is equal to this side of this other triangle, corresponding parts. Okay, so then since I have this angle is equal to its intercepted arc, this central angle is equal to its intercepted arc, I can then say that equal chords have equal arcs, and equal arcs have equal chords. Okay, that moves us along to that. Okay, let's then, I'm going to stop the video here because I think I can only upload about 15 minutes at a time, and then I'll do part 2 in a minute.